Okay, now let's talk about comparing fractions. So in case I forget, what you got to do is you need to make sure that you pause after each one so you can work it out too. So this is like a mini lesson kind of thing. Okay, so here we go. Let's do this first. We're just going to be comparing fractions. So let's look at these two. What is bigger, 2/5 or 4/5? You may say, well, Mr. Schneider, I know this one. So I want you to pause it, work it out. Okay. 4/5 is bigger. Yeah, because look, if I have candy bar that's cut into 5 pieces, I'd rather have 4 pieces, 4 of those 5 pieces, than 2 of those 5. Now, where it's going to get trickier now is what if I give you, I don't know, 10/21 versus 3/7. Okay, now pause it and figure it out. Okay, welcome back. Now, you could remember, I don't know if you remember this, like, did you ever do cross multiplying last year? Well, you could totally do that. But what if, do you notice anything about the denominators? We have a 21 and a 7. Can like one turn into another one? Is one a factor of the other one? And you may say, well, I guess, 7 does go into 21. 7 goes into 21 evenly. How many times does 7 go into 21? Do you remember? Yeah, 3. So you could rewrite this if you wanted. This could stay 10/21. I'm going to put it over here. This could stay 10/21. But what if you multiplied this 7 by 3? Well, if you did that, you'd get 21 for an answer. But with fractions, you got to scale them both, okay? So if you do the bottom by 3, you got to do the top by 3. That's just the rule. So 3 times 3 is 9. Oh, now they have the same denominator. We can compare them. So because of that, 10/21s is bigger. Okay, let's look at another one. Let's look at, is it good one? 9/35 versus 5/7. Okay, figure it out. Now, we may look at these and say, okay, 7 can go into 35. 5 times, I think. So let's rewrite this. We have 9/35, and we need to multiply 7 by 5 to get 35. So we've got to multiply the top by 5. So then what we have is 5 times 5 is 25. 5 times 7 is 35. Oh, well, that's a lot easier than it looks. That's bigger. Okay, so let's look at some more. Let's look at, what if I have 5/4 versus 5/7? Okay, well, if one candy bar is in 4 pieces and one is in 7 pieces, the 4 pieces are going to be bigger. So that's bigger. So now let's look at this one. What if I have 1/3 versus 3/8? Which one's bigger? Now you may say, oh, Mr. Schneider, the 3 can't go into the 8. You're right. It can't go into the 8 evenly. But can the 1 go into the 3? Can the 1 go into the 3? Well, yeah, it can, 3 times. So let's do that. So let's bring it over here. Keep this as 3/8. And then 1 times 3 gives you 3. So I got to do the bottom, times that by 3. So now my new fraction, which is the same as the old one, is just scaled up a little bit, is 3/9. Now which one's bigger? 3/8 or 3/9? And you may say, oh, 3/8, because the pieces, even though there's less pieces of that candy bar, there's going to be bigger pieces. 3/8 is bigger. Okay, let's do one more. Let's do, how about 4/5 versus 8/11. Okay, well, the bottoms, they can't really turn into each other easily. Oh, but the tops can. If I double 4, I can get 8. So, let's see here. I double, and I have to double the bottom. So now I'm going to get 4 times 2 is 8. 5 times 2 is 10, 8/10. So now I have 8/10 versus 8/11. Oh, the 8/10 is bigger. Well, there we go.